Start.
Good evening, everyone. Today, I'm going to present a globe titled Vehicle Insurance Management System by S. Aditya, Ankur Sai Teja, and Sai Pranav. This project was developed as a part of a database management system coursework under the guidance of Dr.Y.Krishna Bhargavi. The main objective of this project is to create an efficient and scalable database system for managing various aspects of vehicle insurance. This project addresses the inefficiencies of traditional paper-based and file-based systems in insurance industry. These methods are prone to errors, time-consuming, and lacking scalability, making them unsuitable for managing large-scale data systems. Our system provides a centralized database for reliable data storage, automation of tasks like claim validation, real-time notification for policy renewals and claim updates. Now let's move on to the need for project. In the vehicle insurance industry, effective data management is critical for operations like issuing policies, processing claims, and collecting premiums. With traditional systems, the industry faces the following major challenges: data inconsistency, manual errors, lack of automations, customer inconveniences. Our system addresses these challenges by storing data centrally for easy access, automating processes to reduce delays and errors, providing real-time tracking and notification to improve communication and transparency with customers. In short, this project modernizes the insurance management process, making it efficient, transparent, and customer-friendly. Now, my friend Pranav will be taking over.
Thank you, Aditya. So, coming to the end users of the project, there are different types of end users, mainly from insurance companies, agents, customers, and administrators. Users from insurance companies handle large scale customer and policy data, whereas agents manage renewals and assist customer with claims. Customers track their policies, claim status, and payments. Users such as administrators are for analytics, reporting, and fraud detection. So now coming to the requirement analysis, customer data management is a management where we store and manage customer information. Vehicle data management is about customer owned vehicles, and policy data management handles policy creation, renewal, and expiry. Claims processing automate claim filling and validation. Payment tracking is used to record and manage payments for policy premiums and claim settlements. So I hereby conclude my explanation, and Teja will continue the further explanation.
Thank you, Pranav, giving this opportunity. Here I am continuing the conceptual database design. Here we are using the entity and relationship models, which is ER diagram model. In this, it contains a basic call as tables and as a variables call as relations. Here it contains the attributes, which shows the relations to those tables, and the table shows the relationship to the entire data structures. Here we are using the key entities as a customers, vehicles, policies, claims, and payments and notifications. In the customers, here you are holding the policyholders and the vehicles as a insurance under those policies and policies which has been taken on those vehicles and the claims which has been done for those policies which are made with an accidents or any such conditions of a repairs and the payments of those claims and their notifications on the based on the situations. Here the relations are we have used here only on the perspective of a customer owns a multiple vehicles with him. In that each vehicle should linked with any insurance policies. The a policy can have a multiple claims that can be monitored by a policies and the claims. And here payments are tied with insurance policies. In this here diagram, now I am explaining the ER diagram, which is a base structure of our code or a database. In this, we are primarily taken as a customers table. In this customers table, we have taken as a customer ID as a primary key entity and the remaining full name, address, contact, email address, and etc. are taken as a attributes. And it is connecting with the vehicles with a like a customer has a vehicles, which is an attribute. In this, one can link with many attributes. In the vehicles, we are taken as a vehicle number as a primary key, and the customer ID can as a candidate key, and the years of manufacture, which is also can be taken as a any of a type of keys. And in that, vehicles can has handles agent performance. Like vehicle from vehicles, we can handle the agent performance, and from the customers, we can receive some notifications about the claims. So we have kept as a notifications as a separate table where notification and number ID is a primary key. In the vehicles, here now coming to the vehicles, the vehicles has if we are met with a accident for the coverage, we have met with the vehicle insurance vehicle insurance table. In that, insurance ID as a acts as a primary key, and the policy ID and the vehicle ID are taken as a remaining attributes for the if it is met to cover the details of it. And to know the vehicle insurance is exist or exist, for that we created a policies table which has holds the policy ID as a primary key, which is most important for this in the to check that it is validate for us. So insurance as a policies can be applies to insurance, vehicle insurance or not, as a we have linked with one with many. So that here we have covered this policies table. For if it the here we have a situation arises that it can be claimed or not claimed. So for that we have made a claims as well as payments table. For that, which can make them to know the claim is possible or not. And now we are continue for another thing, as this is a and this is a logical database design also as the same as the primary keys, and we have providing the foreign keys as well as the policies for the all the tables which are linked based on the ER diagram. From now here onwards, my friend Aitya will continue.
Thank you, Teja. Now, in this next section, in this next section, in this section, we focus on how database structure for the vehicle management system was created using DDL commands. These commands are fundamental for defining and organizing the database schema. The goal was to design a robust and scalable structure to store and manage the system's key entities, including customers, to record customer details like name and contact information. Vehicles, to store vehicle specific information like model and registration number. Policies, to manage insurance policies with attributes like coverage amount and expiry date. Claims, to track claims made by customers. And last, the payments, to handle premium payments and claim settlements. We use using DDL commands, we create a table to represent each entity in the system, define attributes for these tables, specifying data types and constraints, establishing primary keys to uniquely identify records in each table, linking related tables using foreign keys, ensuring referential integrity, and and we have added constraints like not null, unique, and on delete cascade to maintain data consistency and enforce rules. Now my friend Pranav will be taking over for me.
Thank you, Aditya. Since we have completed creating tables, it's time to retrieve data from them. So here is a query to display customer ID, full name, contact number, and driving license. Similarly, we can retrieve data from other tables. For example, if we take a query uh, based on uh, based on displaying the full name from customers, where customer ID is 5, we'll get the output as okay. Wait, there's an issue. Michael Brown. Uh, and we have even used triggers to maintain the data integrity. They also help in sending notifications or raise alerts when specific events occur in a database. Below are the SQL codes for the triggers we use in our database management system. For example, customer trigger, which makes the tables consistent and maintains its data integrity. And hereby Teja will continue the uh, explanation.
Thank you, Pranav. Now here I am continuing the procedures. It is a main key role of handling the entire ER diagrams. In this, we have shown one example of an updated agent's performance procedure. In this, we have connected an action that if an agent ID has taken as a primary key identity and agent activity as a name, way that it has been taken into consideration. In this, we are given an if condition, if else condition that if in this based on the activity type what they have done, if the activity type matches to the one condition, then it goes into the claims policies. Otherwise, it goes to into the payments policies. Based on these procedures, we can control the what we can ensure that the claim is possible or not. This procedure helps in mainly in actioning the base at crucial time of the situations in the databases. And for the customers satisfaction, we can use these procedures. And hereby, I will continue.
Thank you, Teja. Next, next for the tools, for the references and tools used, we have utilized the following tools and references to develop our management system. Oracle 10G. This was chosen for its scalability and robust features, including PL, SQL supporting for triggers and procedures, and referential integrity and enterprise level data handling, and SQL. This is SQL was used for creating and managing the database with commands for DDL for structure definition, DML for data manipulation, and DQL for data retrieval. Now, to conclude, the vehicle insurance management system was developed to address the inefficiencies in traditional insurance management methods. By implementing a centralized database using Oracle 10G, we successfully streamlined data management, reduced errors, and enhanced the user experience for all stakeholders. Thank you for your time and attention. This concludes our presentation on vehicle insurance management system. Thank you.